Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to Groundwater Hydrology and Management. This is week 6, lecture 1. In the past week lecture, we looked at the groundwater components and we are going to move into more focused groundwater applications. Before that, we are in need to understand the recharge and discharge process, which will be covered in this week. So let's look at groundwater recharge and discharge from the water cycle perspective. You have the water cycle in which you have your hydrological components, which is mostly your precipitation going into the atmosphere as clouds, condensation, and coming back to the land surface. It is important to understand the key paths in which groundwater gets into the system and out of the system. So, for example, your ground is your base for understanding the groundwater hydrology, and how water gets into is quantified as groundwater recharge, and how groundwater comes out in terms of natural, which is seepage into the freshwater lakes, springs, etc., and also to the oceans are called groundwater discharge. Now, because of recharge, they can also be discharge. Same, because of discharge, they can be recharge. We will come into how these two components are interlinked. Also, there is a human component or anthropogenic, wherein you do have groundwater recharge because of augmented recharge, induced recharge, etc. On the other hand, there is groundwater discharge through human actions, most importantly when you pump out. So in this week's lecture, we will look at the key paths in which groundwater recharge and discharge happens. More importantly, we will look into methods to quantify groundwater recharge and discharge. In the first class of this week, we'll also look at how groundwater recharge and discharge forms key components in the hydrological cycle. If you look at the cycle here, for example, if groundwater recharge doesn't happen or discharge doesn't happen, what do you think will happen is that this water will never get into the aquifers, nor it gets out as base flow. So the cycle would be more faster because every water that falls on the ground would either be stored on top as lakes and rivers, or it runs off back into the ocean. Whereas the groundwater recharge actually delays the water in completing this cycle. These are much faster time steps compared to the groundwater movement. So basically, your water goes through a slower cycle and it takes some time for recharge and discharge. If you look at here clearly, when groundwater is coming into this phase, for example, at this particular location, groundwater is recharging. And if it is taking this path to go out, it is discharging. But in between, like for example, this point, groundwater is recharging, right? Because water is flowing through, it recharges. It doesn't stay long, but then it discharges out. So this is where the connections happen. But more importantly, on this water cycle that we used to see a lot of these hydrological components, groundwater is a key component without which most of these cycles would not complete itself, and or it will be more flashy as in quicker. So that is why I'm again saying that groundwater recharge and discharge are key components in the hydrological cycle. Let's look at what forms the basis from the hydrological cycle. Yes, the water balance equation. How is groundwater defined here, or groundwater recharge and discharge? So your del S in your hydrological cycle is the net storage in the basin. Okay, let me draw a quick basin for you, or an area. So this is your area, maybe it could be your watershed, basin, whatever it wants to be called. Okay, and you have del S is the net storage within this basin, del S. Precipitation is what comes in, P. Q in is what comes in as surface water. Q out is what goes as surface water. ET is loss, so it goes out. Okay, all the minuses are going out. So this is ET loss, this is your Q out. And then you have your groundwater in, which is from the basement. I'm saying, okay, this is the groundwater coming in and groundwater coming out. So I'll explain all these terms in the hydrological cycle. However, for our this week lecture, these two components are very important because they define what is G in as groundwater in, which is your recharge, and G out is the groundwater discharge coming out. So for a system, you have in the hydrological cycle, in the water balance equation, a groundwater coming in, which is called recharge, because this is your system and groundwater is coming in. Actually comes from the bottom, but you can also show that just as a vector it's moving in. Then you have groundwater out, which is you're taking out. Groundwater out can be from the bottom as groundwater seepage or pumps you take out. So del S is change in water, gives the total net water storage. It is the change in any of these components. You can have storage inside your basin by ways of soil moisture, surface storage, or groundwater storage. G in is groundwater in, groundwater recharge to the system. Can also be from different basins, so it is complex to get at, which means it's not only from your hydrological basin, it could be from a different aquifer, different basin, because it moves under the basin. Okay, so on the top, rainfall cannot come from other basin to inside unless it is coming as Q in. So please understand that G in is a very complicated parameter. It cannot be just estimated using your basin boundary. Some water can come from more than 100 years / kilometers. 100 years means it took 100 years to travel. So think about how far it should have traveled without all these disturbances and get into the system. So that is your groundwater in, which in this class we'll be looking as recharge. Groundwater out is the total water of groundwater used by pumping for agriculture, industrial and domestic uses. So what happens is you have a pump and you take it out, and that is discharge because you're taking out the water for agriculture, industrial, domestic use. The other is natural, where you have deep-rooted trees like eucalyptus and plants and other things which take water out. That is also kind of a discharge, but it goes into evapotranspiration. So there is some part of double calculation in these. So it's better to say ET is the water taken out by plants. However, when you pull the water out by trees, some water is raised up in the soil and it discharges out. Okay, so not all water is going to be taken by plants. So that is the small component in groundwater discharge. But most importantly, groundwater discharge happens naturally as shown in the previous water cycle by just seepage. It goes and joins the ocean, it goes joins the rivers, etc. So let's look at the area to give an idea of how it looks like in terms of a basin. So you have a basin, right? and assuming that the water recharge is happening within the basin, just this basin. Okay, so you have a basin boundary, and you have, as the previous water balance equation I showed, you have precipitation coming in and evapotranspiration going out. Here it is called as just one equation. Then you have Q out, which is your surface water going out. There is no Q in because it is a basin closed for the water to come in. What you see here is there is a recharge area. So when precipitation is falling on a particular area, all this area is contributing to recharge. So this is the area for recharge. Whereas for discharge, it doesn't just discharge here because there's no elevation gradient or a water body that the groundwater wants to flow into, because groundwater flows from high potential to low potential. So here there's no water body that flows like that. What happens is along the channel, because the channel is already in a lower elevation and the groundwater potential is high in the groundwater, low in the stream, the water would discharge out. So it will move like this and come out into the river. And that is what this area is called. The dotted area is called the discharge area. Okay. And look at the discharge area. You also have some evaporation along with the discharge area and transpiration. Whereas all the precipitation is very much less here because already discharge is happening and precipitation will still fall on this area. Some recharge, but all the recharge would just come out as discharge. Okay, so in a recharge area, precipitation is happening, your evapotranspiration is happening, and there is a recharge into the discharge area. So recharge, and then recharge water goes and discharges out of the discharge area. So this clearly explains the steady state hydrological budget in a small watershed, wherein Q in is equal to Q out, and it doesn't change. Okay, so most important, what we need to understand here is the recharge area and discharge area can be within the same basin. However, they are differentiated because of the function, and the function as in how precipitation comes in, how recharge happens, and what is the area for discharge. So with this understanding, we have a bigger groundwater recharge area compared to discharge area. In most cases, the recharge area is bigger than the groundwater discharge area, how groundwater comes out. So we know that when recharge happens, your storage changes, it goes up. Similarly, when you pull out water or water goes out of the system, the level goes down. So there is a fluctuation in the groundwater level. It is important to understand why these fluctuations happen. So let's look at a particular study from the Freeze and Cherry groundwater book, where they look at how these important mechanisms that lead to fluctuations in the groundwater. Fluctuation means the water level fluctuates. Just to draw a small thing, what do you mean when you, because this term would be coming often in your books and stuff for groundwater. So this is your level, okay, the initial level. The level can go up here or down here based on if it is recharge, which is this one, or discharge, which is this one. So discharge is lowering of groundwater table because you're pulling water out, whereas recharge is raising of the water table because you're recharging water in. So this is your new water level. I hope this is clear because it is important to understand the following notations. Let's go one by one. And we know what is the difference between unconfined and confined aquifers. We know what is natural and man-induced. Natural is it happens naturally in the ecosystem, whereas man-induced is the human interface is pushing that phenomena to happen. So what you see on your first column is your phenomenon, process. And then the next set of column is whether the aquifer is unconfined or confined. Moving on, we have a next column, which is natural or man-induced, to show what is a key process driver for this phenomenon. Then the next is your duration. Is it short-lived? Diurnal means mostly daily. Seasonal, you have a couple of months, or long-term. And then you have climatic influences. The climatic influences could be natural or man-induced. Let's not get into that. Here it is climate, how the climate can induce it. So let's look at the most important common processes that result in the fluctuation of the groundwater table or level. The first one is groundwater recharge infiltration to water table. So as I said, we do have groundwater recharge happening. So let's take this as the land, and then you have water coming in, right? So just gonna change the color for this one. Yes. The first one is groundwater recharge happening, infiltrating into the water table. And this is your water table, for example. So the first process just documents the slow movement of infiltration and later percolation into the groundwater table. It can happen only in the unconfined aquifer. Why? Because let me also draw the unconfined and confined aquifer. So this is the second layer, which has a thick impervious surface, and this is your 1 and 2. Okay. And this is your bottom layer, bedrock. Great. So let's move on the first groundwater table. The groundwater recharge moves through from rainfall or some other water applied like irrigation. You have a tank which is leading into a canal irrigation, or just water flowing on top. Water can irrigate like gardening and etc. Right? So that water can infiltrate into the ground and raise the water level. That can happen only in the unconfined layer, because the unconfined layer is open to infiltration, whereas the confined layer is not going to change. So there is no tick mark. There's only a tick mark in the unconfined layer. Is it natural or man-induced? Mostly. So yeah, there could be some man-induced, like you can push water through focused infiltration processes, but in general, it is natural based process. Because of soil, because of rainfall, because of gravity, you have infiltration. And that actually raises your water table. Okay. It can be man-induced also. So let me put a small tick here just to show that you can have groundwater recharge networks, surface ponds, okay, farm ponds, etc. that we saw, we will be seeing. Everything is there. Is it short-lived, diurnal, or seasonal? Mostly it is seasonal, because a rainfall happens not very short-lived. It is not daily, just within a day it will change. It is a seasonal pattern. Okay, not long-term, because every season you do have recharge. Is it influenced by climatic factors? Yes, because when climate extremes happen, for example, your flood, there will be more rainfall happening and stagnation of water, so water can recharge. What happens in the drought, which is also a climate extreme? There is no water. When there's no water, there's no recharge. Then what happens is you have extreme events also, and a slow tapering event, which is your increasing rainfall, not a flood I'm saying, but rainfall is increasing and your temperature is increasing. So when you have high temperature, water is less, so infiltration is less, because all the water will be evaporated. So all this is the first row, which talks about groundwater recharge through infiltration, which affects your fluctuation in the water table, can happen through climatic factors. Moving on, the second one is air entrapment during groundwater recharge. So think that when groundwater is coming, your recharge is happening by the first process. Okay, so when groundwater recharge is happening, and we have to thank Freeze and Cherry's book, which has documented everything very meticulously. These constitute all the major processes for fluctuation of water table in the water cycle. And we can differentiate that as recharge and discharge. Okay, so a big thanks to the book. And we will look at the first thing, which is air entrapment during groundwater recharge from the recharge. So the first one was the recharge. And then while the recharge is happening, think about this. You have land. Inside you have soil with porous space. And the space has air or water or none. Okay, a combination of both or none. Suppose the air is present in the porous space. So when water comes in, the air either has to be displaced. Okay, so the air sometimes get entraps during the groundwater recharge. How does that influence your water table? Basically, you have less water going into the water table to have fluctuation, or the water bubble can go into the water table and raise it until the bubble breaks. Okay, so that is only in the unconfined layer. Only in the top layer it happens. It doesn't go in. It doesn't go in the confined layer because air moving that far, it cannot. Because by the time it moves into the small pores and goes down, it's ripped into very small particles and it doesn't become a bubble kind of thing or entrapment. It is purely nature-based because water is being pushed by the groundwater recharge. And it is very short-lived. In fact, it is one of the least important processes for groundwater fluctuation. However, it fluctuates. And it is also influenced by climatic factors. Because if it's a very hot surface, then all the water is taken out, full of air is in the soil. And then when the rainfall happens suddenly, before the air can escape, a big rainfall pushes the air bubble inside. So the air bubble gets entrapped. But what it is the entire process of the fluctuation of the water table is just short-lived. It just blip and then comes down. This is important to understand while you're in the field, because a lot of these field instruments will throw this error at you, sudden error. And you'll be like, oh, there's no rainfall, or that was not big rainfall, or why is it short-lived? Suddenly there's a blip and comes down. And that is explained by air entrapment. And many other instruments also have this, like, for example, the discharge measuring devices, water flow. Suddenly there is an eddy current or a water air droplet which is stuck in the machine. The next one is evapotranspiration and phreatophytic consumption. Okay, let's just keep it as plant consumption. It happens in the unconfined layer. Again, we're talking about plants and trees that are accessing water only from this layer. So when they pull the water out, eventually your groundwater table goes up and down. It goes up slightly when the water comes in because of the pull, but most importantly, water is pushed down. The water level is coming down because more water is being sucked out. So this happens also as a phenomena in the unconfined aquifer. It is by natural based system because plants are nature based systems. It is not short-lived. It is diurnal. Why diurnal? Because the growing cycle is also diurnal, right? Because the plant sucks the water only in the daytime when transpiration happens. After that, it shuts down. So suddenly you see a groundwater plummet and then it slowly comes up, comes down, goes up, comes down, goes up. And this sinusoidal nature of the water table mimics your water use of the plant. Okay, when the plant takes more water, it goes down. And when plant shuts down, sun shuts down, there's no photosynthetic reaction taking place, then the water recharges up. Okay. Moving on, then it is also influenced by climatic factors, because when there is different climatic pressure on the plant water consumption is different. Bank storage affects near streams. So for example, you have a stream, you have a river flowing. Near the river, there could be some water stored because of the flood. Okay, a big flood is coming and the bank is full of water. That can also influence your unconfined aquifer, the first layer in the aquifer, because the water can rise based on the bank water storage amount. It is purely a nature-based system, and it is seasonal because your river will have water only during seasons. When there's no water flow in the season, there is no water in the river and it is dry. So the water table is down. Once water flows from your river channel, from your bank, water will come down into the groundwater aquifer and recharge your aquifer. It is also influenced by climatic factors because based on the climatic factors, you have water coming into the river. Because if there's a big rain, a lot of water will come in the river. And that water will flow as flood, and the flood will induce recharge. Tidal effects near oceans, similarly. Okay, similarly, you have big waves, big tides that will come and hit the coast. And that happens in a cyclic pattern also. During certain periods of the month, you have a bigger tide and then small tide, big tide, small tide. So when this big tide comes, more water reaches the shore and that water can recharge. So that is also a unconfined aquifer effect, but because the volume of water is too big and it pushes, the water comes in a big force, it can also impact your unconfined aquifer. So both unconfined and confined aquifer can be influenced by this tidal effects. It is a purely nature-based system, even though man-induced climate change and other things can happen, and it is diurnal nature. If you go to the beach, you'll see that during the night, the wave is high. Okay, during certain peaks of the month, it is high. So it's not a seasonal, it is between the seasonal and diurnal. Diurnal is daily. Okay, seasonal is a couple of months once. So you could see that the water recharge through tidal can happen in a nature-based system. It is diurnal daily, it happens because day, night. Okay, and it may or may not be influenced by climatic factors. Atmospheric pressure effects. So when the atmosphere pressure is different, water can come out because water flows from high potential to low potential. For example, outside the well, if the atmospheric pressure is low compared to high pressure of the water inside, then water flows from high pressure to low pressure. You have automatically flowing wells, which are called artesian wells. We saw this in the first couple of classes. Okay, and that is purely happening as a climate influence factor because the climate changes your atmospheric pressure. It can happen from unconfined or confined aquifers, basically where your well is placed. Okay, and it can happen from that aspect also. And also it is a very natural based system because it can happen only from a deep well and because of the atmospheric pressure. Humans cannot control the atmospheric pressure. It is diurnal in nature and can be influenced by climatic factors. Diurnal because every day in some aspects it can happen. External loading of confined aquifers. So you have unconfined and confined aquifers, but external loading can happen. You can put pressure on the aquifer, and as the name suggests, it is only going to be in the confined aquifer. Okay, only confined aquifer layer is there. And as an external loading happens, it can happen naturally, but only once. It's not a big thing to record, but it is a man-induced part. So that happens in a couple of times. Then it is because of human-induced. It is very, very short-lived. Suddenly you put some loading. For example, you bring a big couple of tons of cement and blocks and put it on top of the aquifer. It just pushes your aquifer and suddenly you see a jump fluctuation. There's no climate and other things. Earthquakes. Earthquakes are the process in which the plates very, very deep near the bedrock, near this area, I'm saying, where the rocks and other things would move. So when they move, the water table also fluctuates because if suddenly there's a crack, then this water will flow down, water will come down. Or if there's a crack and water flows out of the system, then this water level will go up, right? So these define the water level fluctuations because of an earthquake. And it happens only in the confined aquifer because of the depth. It is a nature-based process and it's very short-lived, just a couple of minutes, that's it. It's not going to be every day it's going to shake or every season it's going to shake earthquake. Groundwater pumpage, the most important aspect in groundwater fluctuation. Pumpage can happen from unconfined or confined aquifer based on where you're putting the pump. You can have one pump in the unconfined and one pump in the confined. So you can pull the water out, it can change. And it is a human-based process because you are the one who's going to control the pumps. It is also long-term effect because once you pull it, the water table will take long time to stabilize. It's not going to fluctuate and then stay there. It just takes slowly, or easily you'll pull it out. So suddenly the water table will fluctuate down, but then the recharge happens very slowly. Okay. Deep well injection. This is also a human-induced process and injection. You put in water. Okay, and it is in the confined aquifer. So the confined aquifer is here. You put in some water for some process, fracturing, or you want to put in a pollutant water like some people do, very bad, polluting the environment, or you want to actually recharge or keep it in the ground so that you can use it during the later season, like UTFI project I mentioned. So this deep well injection is based on a reverse of the pump. Instead of pumping out, you're pushing water in using energy. It is a confined aquifer process, man-made, human influenced, and it is also a long-term. Similar like your pumping, it is also long-term. Artificial recharge, leakage from ponds, lagoons, and other landfills, it is where you create or you induce more recharge. And that happens mostly in the unconfined layer, the top layer, because that is where most of these small structures would push water in, not to the deep aquifer. Okay, it is man-made because it is artificial. Just know this word, it is artificial, injection, pumpage, all these are caused by humans. So that is defines if it is human or natural. And it is also long-term. Okay, it is not a very short-term process because it takes time for it to go in and stabilizes the water level. Then we come to agricultural irrigation and drainage. So agriculture itself is a man-made or human-influenced process. It is happening only in the unconfined region because agricultural irrigation, not agricultural pumping. Okay, agricultural irrigation, you're going to put water on the surface and water recharges. It recharges only in the unconfined layer because the roots are only here. The plant roots will only grow to here. It doesn't grow much, right? It is a man-made because agriculture is not a natural process. Forest and other things are natural process. And then it is also a long-term like pumpage, etc. Whatever is human-induced, it is long-term impact. It can be influenced by climate because the climate factors influence how the plant grows. Geotechnical drainage of open pit mines, slopes, tunnels, etc. This is the geotechnical drainage because you push water into these kind of pits, mines, etc. So mine, when you have a mine where they collect the ores and stuff, they have a specific space where they can put all this, dump all this water. Slopes, tunnels also, when they cut, there's some space where the water goes in. Okay, so suddenly you see an influence on the unconfined aquifer. The unconfined aquifer changes the level. It is a human induced process. It is also long-term. So there is no climatic factors. So what is the take home here? There's multiple things that can change the water level either by recharge or by discharge, taking out the water or putting in the water. What you see is the nature-based processes are either seasonal, short-term, or diurnal, whereas the human-based processes are long-term. So when you disturb a system and it takes long-term to stabilize, that is not sustainable. You cannot do it continuously. Okay, for example, the bank storage can happen continuously because every season the water comes, it's fine. However, your pumping, injection, artificial recharge, agricultural irrigation, which is also artificial plants and vegetations you're growing not by natural process, and geotechnical drainage. All this has an influence on the groundwater aquifer. because you are pushing water or you're extracting water. And the more key driving home message, or the drive home message, is these take time. It is also influenced by climatic factors, but most importantly, it takes a long time for the water to stabilize, the fluctuations to stabilize. So you cannot plan what is going to happen next. If I take too much water, the water level comes down. And before I know how much water is there, I again pump and again pump. And that is why the groundwater resources are very low in the country, especially India, where most of the groundwater is extracted. I hope these messages were clear to understand, all the important process through which fluctuations happen. I will see you in the next class, where we go on to discuss each one process in particular, because recharge is different than discharge. So we'll go on into see how recharge happens and how are they estimated. Same way we'll go to discharge and see how discharge happens and how it is estimated. Thank you. I will see you in the next class.